we're going to go ahead and use identities to evaluate a function. And that is, we're going to use secant u equals to -3/2, and our tangent is going to be positive. And we want to find all 6 trig functions. Now, we did this actually before in chapter 4, but this time we want to use our identities. And so let me just turn real quick to a page that has all the identities. And I think you have all these written down already, but if not, you might want to pause it right here and then just go ahead and copy down all these identities. We're going to be using these repeatedly in this chapter, chapter 5, proven identities and using identities to solve trig functions and so forth. So have this all written down, and we're going to go ahead and use that in the following problems here. Okay, so just so that we can see what quadrant we're in, and then we're going to tackle this. Okay, we know that if, so we're saying that our secant of u is negative, right? So secant of u is negative. Well, let's think about this. Secant and cosine are just reciprocal. So that means I can say that I'm looking for a cosine of u that's also negative. Okay? If sine is negative, then cosine must be negative. And then we also have here that tangent of u is positive. So just so that we understand what quadrant we're in, we're looking for a cosine that's negative and a tangent that's positive. Well, let's see. Cosine is negative in the 3rd quadrant and in the 4th quadrant. If you want to figure out if cosine is positive or negative, we're looking at the x-coordinate. So the x-coordinate here is negative, but if tangent is positive, so I know that we're going to be over here. We're going to be in the 3rd quadrant. Okay, and sometimes it kind of helps just to know what quadrant we're in, and especially when we start dealing with the signs here, because it says we need to find all 6 trig functions, and it's very, very important that the signs are correct, and you know that the signs are correct if you know what quadrant we're in. Okay, so but we're not going to use a triangle here, right? I mean, we could make a right triangle and then solve for this, but that's not the approach here. We want to use our identities. Okay, so we're going to use an identity that maybe has secant and tangents, but maybe let's take a different approach here. We know that the cosine of u, okay, that's the same thing as 1 over secant. Okay, and that's one of our identities. Well, we know what secant of u is. That's up here. So I'm going to replace secant of u with -3/2. So that's 1 over -3/2. Well, if you ever have a fraction in the denominator, then all you got to do is just flip it. It's reciprocal. So that means that cosine of u is going to be -2/3. Okay, and the reason why I did that is because I actually want to use this identity right here, and that's sine squared of u plus cosine squared of u equals 1. All right, and as you can see here, I'm going to substitute cosine of u into right here. So I'm going to replace cosine of u squared with -2/3 squared. Okay, so let's go ahead and show all that work right there. So let's see. So I'm going to leave sine squared of u, but then I'm going to replace cosine squared of u with -2/3. But let's remember that we square that guy. All right, and then plus 1. So if we square this, we are going to have sine squared of u plus 4/9 equals 1. Okay, if I subtract 4/9, let me just move down right here. If I subtract 4/9, I get sine squared of u equals, let's see here. If I do 1 minus 4/9, it's going to be 5/9. And so that's going to be sine squared of u. And now let's go ahead and take the square root of both sides. Okay, so that means sine of u is going to be equal to the square root of 5/9, which is the same thing as radical 5 over 9. Okay, so let's go back to what we're actually trying to find here, so we're staying on course. We're using our identities, and we need to find all 6 trigonometric functions. Well, we've actually found two so far. We found cosine of u is negative 2/3, so that's one of the six. And we also just found sine of u is root 5/9. Okay, but hold on. And this is the big hold on here. And this is the reason why we did this triangle. Okay, we need to realize what the sine of our x value is and the sine of our y. Meaning, the sine is the y value, right? So when I say that the sine of u, okay, right here, the sine of u, it's actually not radical 5/9, because that's going to stand for the y coordinate. It's actually going to be negative radical 5/9. And the reason why I know that's because of what quadrant that I'm in. I'm in the third quadrant. And if I take the sine of something in the third quadrant, that's the y value. And notice, the y value is negative. Okay. Oh, I'm sorry. And this has to be negative as well, the x. Okay. So, and I don't know. I mean, you could also put these values right here, but that's just to show that that's the way it is there. Okay. So so we found the first one, and we know that the cosine of u is negative 2/3. So now let's find the tangent of u now. Again, we're trying to find all six trig functions without using a triangle. Okay, the whole purpose of this is just to getting used to using the identities. Well, tangent of u is sine of u over cosine of u, and cosine of u is negative radical 5/9. All over the cosine of u is negative 2/3. Okay, well, we know that, let me use a different color here, that 3 can go into 9, 3 can go into 9 3 times. Okay, and so that means that we would have, wait, 3 goes in that 3 times right there. Let's see, what did I do here? Like negative 5/9. Oh, I'm sorry, sine of u should be 3, right? That should be 3, because the square root of 9, the square root of 9 is just 3. Sorry, there's something that was looking kind of weird there. So radical 5/3. So let me just erase that to make it look nicer. So this should be a 3 right here, and that should be a 3 right there. So 3, 3. Okay, so that's a lot nicer right there, because now those cross out. And so now we just have radical 5/2. And our tangent was supposed to be positive, because if I do y over x, I get a positive value right there. All right, let's now go ahead and find the other trig functions. So now we're going to find cosecant of u. Okay, let's remember cosecant of u is the same as 1 over sine of u, okay, which is 1 over, and then that was radical 5/3. Okay, but we also know, though, okay, this is very important here, that's supposed to be negative, is that we have to flip this, right? So that's the same thing as negative 3 radical 5. But then we have to rationalize this, so multiply top and bottom by radical 5. All right, so we get negative 3 radical 5 all over 5. And as you can see, this is a very lengthy problem. All right, let's keep going on here. We have to find 2 more trig functions. Let's find the, what's next? Secant of u. Secant of u is 1 over cosine of u, which is going to be equal to, so what was our cosine again? Cosine was negative 2/3. 1 over negative 2/3, which is the same thing as negative 3/2. Okay. Last but not least, cotangent of u, which means I just flip tangent, right? I'm just going to flip this. So that's 1 over tangent. But I'm just going to flip whatever we got for tangent. So tangent, if you look over here, was radical 5/2. So that's 2 over radical 5. But then we have to rationalize it by multiplying top and bottom by radical 5. So I'm going to get 2 radical 5 over 5. And we just found all 6 trig functions without using a triangle. However, this time we used purely just our identities.